Hello again, people. I have an interesting project going on and I want to share it with you, even though it's again with my bad camera. So, to begin with, I finished boring the two sides of this roll like this, and I will next make the shafts to fit them, but this came kind of as a slider, so I have to do this Ford rear axle now, and it's turning between centers at the moment. And you see I have this smaller 3-jaw chock in the jaws of the 4-jaw, and I centered it by using this race of thrust bearing. So I set this on the outside of the jaws, and I indicated the outside edge of this race. So because there's no way to indicate this piece here because it's all rough on the outside, but on the inside there's a bearing race that is now resting against the jaws. So it should now be running perfectly true. And on the other end it's just using a large live center to the same bearing housing. And what I got to do is to shorten this shaft, this rear axle I mean. It's gonna be for a race car, and he's gonna attach some really wide tires on it, so I'm gonna have to cut the shaft in here, and also clean this area right here, turn it to be clean and true. So what I'm gonna start with, I think I'm first gonna clean this, and I'm gonna clean a little bit further, maybe around here, so that I can set a steady rest in here, and in that way I can part the shaft, I mean the axle from here, and then I think I will turn this axle around and remove the 3-jaw and grab with the 4 jaws in here and indicate from the surface that I just turned, and then repeat the cutting procedure here. And that's how I'm gonna do it, trying to keep it as straight as possible. Not sure how straight these axles actually are, because this is welded. It's not even a casting, it's welded from different pieces. It's got welds here and the tubes are welded and everything. But I'm still doing my best. And on top of it all, of course, I have to make some new flanges with the bearing holders. But that's not gonna happen today. Okay, maybe I will show you how I do this. Okay, as I thought, it is actually running out quite a bit. So I'm not sure if the tubes will clean. Let's see. Okay, it just looks worse than it is. Actually, there's only about 1 millimeter of runout, which is just fine, because I got some holes here for some reason, and it looks like the material is like 4 millimeters thick. So it will be thinner, but I think it's gonna be enough. And if it's not enough, I think we can later weld some supports here. So I'll just proceed with the plan. Okay, this is not easy. The shaft is so, I mean the pipe is so thin-walled and long that it really likes to chatter. So I'm running a low speed and a high feed, and I even taped my gloves on to help with the harmonics, and now it's going relatively well. I'm now roughing, but I'm hoping that I can actually make the final pass with no chatter, hopefully. Let's see. Now trying to do the finishing pass. It is still chattering, but it looks like the surface finish is somewhat better than with the roughing passes. Let's see when this is ready. Okay, now that I have the steady rest in place, the parting wasn't actually that bad, but it still had quite a bit of chatter. But I managed to do it. It's now punched through on one side, so here we go. Now what's left to do, I will clean this face, and also for some reason I managed to leave a little bit of shoulder in here, so I'll have to turn that away. And then for the other side. How can this focus be so bad? Awful. Okay, now the piece is turned around, and I also turned the inside of the tube, so I decided to use the 3-jaw again. And it seems like it is running almost perfectly through in this end, which is good. And for some reason this end is going a little bit nicer. Maybe that's because the a little bit is removed from this end already. So just trying to clean this so that I can use the steady rest and then do the parting and cleaning the inside of the tube a little bit. And by the way, from now on I will remember to set up the steady rest before I set the workpiece, because it's quite a pain to slide the steady rest under the workpiece. Okay, so I'll get back to you. And now finishing, which is actually turning out pretty good, I think. And if you were wondering, I still am turning at 90 RPM, and the feed is 0.32 millimeters per revolution, which is, I think it's about 12 to 13 thousandths of an inch per revolution. So slow on feed and fast on feed. Slow on speed and fast on feed. And also what's bad for vibration is that I have to hang out the tool so long because this leaf spring support is hitting my tool post if I don't do that. Okay, almost ready for the steady rest. Okay, let's see how we do with the parting. Switching the lowest possible feed, which for cross feed is 0.04 millimeters per revolution, which is less than 2 thou. So, here we go. Should be better than last time. Oh yeah, this is good. This is really good. Now cleaning the inside and then doing a chamfer on the outside. And also deburring on the inside, of course. It's quite a bit shorter now. by the way, the differential is located a little bit more close to this end than this end for some reason. Okay, the inside is now chamfered using this handheld tool. And now the very final thing is to chamfer the outside edge. Mostly for welding the new bearing caps in place. Using this 90-degree tool. Okay. Another project finished. Too bad this side didn't come up nearly as good as the other one. I think I could still flip this around and put the live center in here and clean the outside, but it doesn't. I don't think there's any point in doing that. Okay, so thanks for watching, and until the next video, which hopefully will be crane build part 4. Okay, bye. And by the way, now I have some stoppers.